Hi, this is Terry, and on this video, we're going to be factoring with the GCF, or the greatest common factor. And all the greatest common factor is, the GCF, that is just the the biggest number or variable or combination of the two that all of the terms in your problem have in common. So to be able to determine this, we're going to start by kind of breaking this problem down. We have 9x cubed plus 12x squared plus 18x. So we're going to separate first all of our numbers on one side, and we're going to put all of our variables on the other side. And we're always going to start with our smallest number. So we're going to look at this 9, and we're going to factor it. So we're trying to figure out all the combinations of ways to multiply to make 9. So we always start with our 1. So 1 times 9 can make 9. And then we look at 2. Can 9 divided by 2, does it come out evenly? It does not. So let's try 3. Can you divide 9 by 3 evenly? Yes. 3 times 3 is 9. So we look and we couldn't go any further. So that would be our greatest, that would be all our factoring for that. So we're going to look, and we always start with our biggest number, and we're like, okay, hey, can these numbers, that 1, 9, or 3, can any of those divide into 12 and 18 evenly? So let's see. We start with our biggest, 9. Can 9 divide into 12 evenly? No, it can't. So we're going to cancel him out. Can 3 divide into 12 evenly? Ooh, yes, it can. 3 times 4 is 12, right? So let's look at 18. Can 3 divide into 18 evenly? Yes, 3 times 6 is 18. So 3 is going to be our greatest number that can divide into all 3 evenly. So let's look at our variables now. We have x cubed, x squared, and x. So when we're looking at these, we want to find the variable with the smallest exponent. So we have a 3, a 2, and this guy doesn't have one. So if you have a variable that doesn't have an exponent, it's just a 1. So that would be our variable with the smallest exponent. So what we're going to do now is we just combine. We have our 3, and we combine that with our x to the 1, or just x, and that becomes our greatest common factor. So we're not quite done because we still have a problem. We want to figure out how this is completely factored. So we're going to bring down our problem, original problem here. And then we're going to take that greatest common factor, and we're going to write it under each one of those terms. So this is something we've learned in a previous video about dividing. And so that's what we're going to do here now. So we're going to take our numbers first in the first term. So we have 9 divided by 3. And we know that that is 3. And then we have the variable x. So we're just going to bring that variable down. And remember, when we talked about exponents before, it's always the top exponent minus the bottom exponent. If there's not an exponent, remember, it's just a 1. So this will be 3 minus 1. Then we're going to look at the second term here. And this will be a plus 12 divided by 3. And we know that is a plus 4. And so we write down our variable and our exponents, the top exponent minus the bottom exponent. So it'd be 2 minus 1. And then we look at our last term here. We have an plus 18 divided by 3. And we know that that is a plus 6. And we write down our variable. And these both, neither one of them have an exponent. So it's 1 minus 1 because they're both just be 1s. All right, so let's simplify a little bit here. So we have 3x, and 3 minus 1 we know is 2, so that makes it squared, plus 4x, and 2 minus 1 is just 1, and then plus 6x, and then we have 1 minus 1, which is 0. However, anytime you have x to the 0 power, you can literally just erase that x to the 0 power. Same thing on if you have an x to the 1 power, you can leave the 1 power, or you can just erase the 1 power and just leave it as an x. So last step here is we're going to put what we just found in parentheses. And then we can't forget that we had factored out a 3x. So we have to bring it back and put it in front of our parentheses because we cannot lose it. And that gives us a completely factored problem. And if you were wondering, did I do it correctly? You can always check yourself. If you remember the distributive property, we just multiply anything outside the parentheses by each thing inside the parentheses. So if you multiplied that back out, you should get your original problem at the top. All right, so let's do one more problem here. This time we're going to have 21 t to the 10 minus 9 t to the 9 plus 15 t to the 4. Okay, and so we're going to start out with this just like we did with the other one. We're going to separate, put our numbers on one side and our variables on the other side. Okay, so we always start with our smallest number, which is our 9. And we've already factored that before, so we're just going to write down what our factor is there. And so now we're going to see which one of these numbers can divide into 21 and 15 evenly. So we're going to start with 9. Can 21 divided by 9, does that come out evenly? It does not, so we're just going to get rid of that. And what about the 3? Can 21 divided by 3, did that come out evenly? It does. 3 times 7 is 21, so that one works. So let's try the 15. Can 3 divide into 15 evenly? Yes, 3 times 5 is 15. So 3 will be our greatest number that can divide into all 3 evenly. So let's go over and look at our variables. And we have a 10, they're all t's, so that's perfect. And then we have a 10, 9, and a 4 for our exponents. So remember, we take the smallest exponent. And then we're going to write that combination down. So we have 3 t to the 4th, and this becomes our greatest common factor. Well, for our purposes, we need to keep going because we want to factor this whole problem out. So we're just going to rewrite down the original problem, and then we're going to take and we're going to write our greatest common factor underneath it. Remember, we're going to do that division. So let's put that greatest common factor underneath each one. All right, and so now we're going to start with that first term, and we have 21 divided by 3. And we know that 21 divided by 3 is 7. And then we have our t for our variable, and it's our first exponent, our top exponent minus the bottom exponent, so it's 10 minus 4. Okay, then let's look at our second one. So we have a negative 9 divided by 3. And we know a negative divided by a positive is just a negative. And 9 divided by 3 is 3. And we're going to bring down that variable. And we do our exponent. So this is the top exponent minus the bottom one. So it is 9 minus 4. Then we're going to look over and we're going to do our third term here. So we have a plus 15 divided by 3. And we know that plus 15 divided by 3 is a positive 5. And for our exponents, it's the top minus the bottom. So it's 4 minus 4. All right, let's do some simplifying. So we have 7t, and then 10 minus 4 is 6. Minus 3t, 9 minus 4 is 5. Plus 5t, and 4 minus 4 is 0. And again, because it's a 0 power, we can just erase that variable in the 0. So now to our last thing, we'll put parentheses around what we just found. And we cannot forget that we had a greatest common factor that we pulled out. So we're going to put that right there next to it. And now we have completely factored our original problem. Again, if you wanted to check yourself, you could do that distributive property and multiply that term outside the parentheses by each one inside the parentheses, and you should get that original answer that you started with.